Yeah. Okay, I hope the screen is visible to you all.
Yes, sir.
Yes, sir.
I'm going to talk about these three topics today, equally giving time to each one of them. I have started the first thread in the last meetings, the second half, known as VM placement. We'll also talk about how VM backup can be done. And then let us start talking about cloud interoperability. Okay. So VM placement, if you can recall, I was talking about two kinds of theoretical problems known as knapsack and bin packing. Right, where we wanted to do the allocation of virtual machines on multiple physical servers which we have in cloud, right? So we may have, let us for example, these 5 servers are there in a cloud and I want to place the virtual machines, right? So on which server the virtual machine will go, if we can decide there, then we are saying that we are trying to follow virtual machine placement approaches, right? In the last meeting, I also gave you an example that how we can generate CPU utilization close to 100% by writing a C program, right? Did anybody, got a chance to run such programs, or any feedback you have? The discussion we had, the floating point operations we were running in a for loop, and then the CPU was busy 100% of the time, right? Then I asked you a question: if I run two programs of a similar nature, both of them running for loop having floating point operations, will they take more time as compared to the situation when only one of them was running, right? So yes, the answer is yes, they will take more time if they are running on the same CPU, right? So what is this situation known as, right? Because there are two processes, both of them are trying to run on the same CPU. They want to execute their instructions. They are not trying to affect each other. They don't know who are the other processes running on the same machine at the same time, but inadvertently, bina jane bujhe, the overall time of those processes is increased, maybe double. This situation, when more than one process, more than one VM is interested in a single specific resource or common resources, and inadvertently they hamper the performance of each other, this situation is known as performance interference. Performance interference. So what should we be doing? कैसे रोके performance interference को? Suppose this is my laptop and there are 5 applications right now running. They all are CPU hogger applications. They require a lot of CPU. What should I be doing so that performance interference doesn't happen? Any idea? What if I run each one of these applications on a separate CPU? I give them dedicated CPU and no other process is allowed to run on those CPUs. Would performance interference still happen?
No, sir.
In that case, it will not happen, right? Because now you are being given dedicated resources. In earlier case, you were giving shared resources. So this is all thing about shared resources versus dedicated resources. But see, the thing is quite easy to understand. but it is not very easy to, have it in production environment or industrial environment, because you went to cloud for the purpose of higher hardware utilization, less cost, and that can only be achieved if you have shared resources. If you give dedicated resources, then the very purpose of cloud may not be fully achieved, right? Because in that case, the costs will increase. You will have dedicated resources, dedicated CPU, dedicated network, dedicated memory, dedicated disks. Then what is the purpose of having virtual machines? Give physical server separately to every application which wants to run out there, right? Now the solution should be in between, not shared, not dedicated. Some of it is shared, right? So sharing should happen in such a manner that we are able to minimize the performance interference. That situation is known as performance isolation. Let us isolate the resources as much as possible, right? Because what will happen in VM placement, when you are keeping virtual machines on physical servers, if you think about this issue, performance interference, then you need to do an allocation in such a manner that a VM which is interested in CPU or very much interested in CPU should not be placed with a VM which is interested in, let us say, network. So they should be placed together. Both the VM should not have interest in CPU thoroughly, right? So different resource interests should be clubbed together. So a VM is, let us say, a static web server. Static web server does not use CPU much. Memory is also not required. It is mostly disk and network. Think about an HPC application, high performance computing application. It does a lot of integer calculations, integer and floating point operations. In that case, you require CPU. So these two applications in two different VMs can be kept on a single physical server. They will not affect each other. If two HPC applications are kept together on a single physical server, they should not be sharing CPUs. Otherwise, they will create problems to each other. This is the whole story of performance interference or performance isolation, right? Today we talk about containers. Containers provide very good isolation, greater isolation, right? Isolation which is better than virtual machines. Okay, so this was one side of the coin, that resource interest or performance interference should be kept in mind while doing VM placement. What should be the other ideas? Other idea is you should place a VM on which place where there is a scope of increasing resources, right? Or you place a VM at such place where the VM's owners, other VMs are already kept, so that they can have quick communication. ऐसा भी किया जा सकता है. Yes. Or you place a VM at such place where probability of migration is low, because migration has an overhead. So all such factors can be kept while doing VM placement algorithms. Now I'll move to a paper which talks about a set of VM placement algorithms. We'll do it quickly so that we can get an idea. There is a lot of scope of innovation. Anybody who is interested in cloud computing can also think about designing new VM placement algorithms, right? One way is, the experiments can be done using simulators like CloudSim, or you can also have a small setup of multiple physical servers, 4 or 5 physical servers, and you can test it, right? So let me move to this paper. This paper says implementation and performance analysis of various VM placement strategy in CloudSim. So they did it on CloudSim. One thing I forgot, you may want to do VM placement for power consumption, right? Minimal power consumption. So last meeting I said in bin packing we have an aim that minimal number of servers should be switched on, others may be switched off to save power. You see, due to the narrow dynamic power range of servers, it has been seen that even idle servers consume about 70% of their peak power, right? So idle server भी नहीं रखना चाहिए, right? Which we can ideally make them switched off. Whenever there is a need, we can start. So let me come to VM placement algorithms. You see here, VM placement requires multiple sub-utilities. The first sub-utility is that a VM should be kept at a physical server. Second, it should be selected to be migrated, right? If you see this one, VM placement. So a VM placement algorithm can be of these types, bin picking problem, right? The first algorithm is known as first fit. We have seen such an algorithm when we were doing disk allocation, right, in operating system. First fit, what it does? First fit starts with the most active bin and tries to pack every item in it before going into the next bin. If no suitable bin is found for the item, then the next bin is selected to put in the new bin. So there is a physical server where the enough required resources are available, you keep it there. Which server? Where you have done recent allocation. इससे पहले जो recent allocation किया उसी server को चुनेंगे and there will keep this VM. This is known as first fit. Second one is first fit decreasing, right? So you sort them in decreasing order or non-increasing order, and then you try to do first fit algorithm, right? Best fit, what is best fit? Where after allocation, the available resources will be minimal. That is known as best fit algorithm. Last, another algorithm is worst fit decreasing. In worst fit, where after allocation of a VM, the remaining resources are maximum. That is worst fit algorithm. And the another algorithm which is there, second worst fit decreasing. You first order them. Don't choose the first one. Choose the second one. Right? So same as worst fit, it just choose bin with second minimum empty space. It is also known as almost worst fit decreasing. Right? So these are the basic algorithms of VM placement, where to put a VM. Coming to other set of two algorithms, that how do you decide you require more resources? On a VM, how do you decide that you require more resources? That comes under set of algorithms which are known as auto-scaling algorithms. Auto-scaling algorithms. So there are few algorithms in that area which are statistical inference based approaches. Median absolute deviation, which is known as MAD. For adjusting upper bound, a statistical dispersion like MAD is used. The reason behind choosing MAD over standard deviation, so we already have standard deviation. This is also a deviation, right? Is that MAD is not heavily influenced by the outliers. So the magnitude of the distances of outliers is irrelevant. So outliers are given more importance. Interquartile range, this is already a very important method known as IQR. This could be said as the second method for setting an adaptive upper threshold. For symmetric distribution, half of IQR is equal to MAD, right? So half 1 IQR is MAD. Local regression and robust local regression. You might have seen these algorithms in your machine learning course, right? So here, these are the ways by which we are identifying whether overload situation has happened or not. So VM placement, overload detection, and third set of algorithm is whom do we migrate? Which VM should be migrated? There can be some set of algorithms. First one is minimum migration time. जिस VM को migrate करने में कम से कम समय लगे. How do you know this? You can predict it based on the size of the VM, size of the RAM, amount of dirty pages, right? We know how migration happens, right? So minimum migration time. Second one is random choice, right? Any VM. So they're talking about uniform distributed discrete random variable XD, right? The third choice is maximum correlation policy, right? in this, a little more innovation is done. You look at the kind of resource uses of the VMs, and then you decide that where, if it is it goes on a place where the correlation will be highest. Now there are many other algorithms which are possible. I just gave you an idea that what sort of algorithms are available. Now this CloudSim was written by University of Melbourne, right? This is an open source simulator available. You can all try create new algorithms over there. So this was about VM placement. I will also talk a bit about performance interference and isolation, an algorithm motivated by that. So this was a paper by one of my students who worked on this. So virtual machine uses based placement in cloud, in IaaS cloud. So what they do essentially, for every virtual machine, they create a vector. This vector is known as resource vector. Resource vector tells things about basic resources like CPU, how much you want, memory, how much you want, network, how much you want, and disk, how much you want. How much means what is the kind of utilization you want to do of such resources. So there can be three kinds of utilization: high, moderate, and low. An application like a web server may have requirement of huge CPU. Another web application may have requirement of very low CPU, right? So this is how we can categorize them. And after this, all VMs are having these values. Then I know the size of the data center or cloud. Then I keep on placing VMs on each and every bin or each and every physical server. And then I make the arrangement. What will we achieve by doing this? We will achieve minimum performance interference and we'll achieve higher performance isolation. So this is the paper which talks about this. Let me go to the real essence of this paper. Virtual machine placement and migration decision-making methods are integral parts of these resource allocation mechanisms. We present a novel virtual machine placement algorithm which takes performance isolation amongst VMs and their continuous resource uses into account while taking placement decisions. Performance isolation is a form of resource contention between virtual machines interested in basic low-level hardware resources, CPU, memory, storage, network, and bandwidth. So what we do? A per VM three-dimensional resource utilization vector has been continuously calculated and used for placement decisions while taking conflicting resource interests of VMs into account. Experiments using the novel placement algorithm ViewPIC, we call it ViewPIC. ViewPIC show effective improvements in VM performance as well as overall resource utilization of the cloud. So this is the overall idea of the algorithm. So let us talk about certain things. What we do is there are certain experiments which we do. Like you see, there is a storage server where all the VM disks are kept. These are three physical servers on which VMs are running. What kind of VMs are running? We have named them CPU 1, CPU 2, disk 1, web 1, web 2. These are the kind of applications these VMs are running. And these applications represent some of the very common applications available across the globe. Right? Web server is one of the very common applications available across the globe. So if you look at this diagram, CPU intensive applications known as CPU 1, CPU 2, where they were placed alpha. This is the first physical server where they were placed. Beta, delta. Disk 1, disk 2, they are disk intensive virtual machines. How do you make a VM disk intensive? You run some specific programs known as disk benchmarks inside them, so they become disk intensive. Network intensive, they run disk network intensive programs like web servers, right? So after our algorithm, what will happen? A rearrangement will happen. Web 2 will run with CPU 1, CPU 2 will run with disk 1, and web 1 will run with disk 2. This is the actual outcome, right? That they should be rearranged so that performance interference does not happen. So there are a set of experiments which are done. This is the resource utilization vector, CPU uses, network uses, and disk IO uses. A CPU intensive applications will have HLL. H means higher CPU uses, low network uses, and low disk IO uses. A network intensive VM will have moderate CPU uses, high network uses, and low disk IO uses. Similarly, a disk intensive applications will have LLH, which means low CPU uses, low network uses, and low disk IO uses. So to make them such VMs, we run certain, set of benchmarks inside them so that they represent such VMs directly, right? So let us come to this summary. The novel algorithm applies an optimization while making rearrangements on the basis of VMs corresponding resource utilization vector. अब एक बात मैं यहाँ कहता हूँ. See, VM placement is an ongoing activity. It continuously happens. A VM comes up, you place it, but the job is not over. You need to continuously look for rearrangements, migration, selecting a VM to get migrated, right? Or identifying whether there is a physical host which is overloaded. Because when will you migrate? A physical host is overloaded, or a VM requires more resources which are not available, right? ViewPick would start arranging the VMs on PMs. PMs are physical machines, VMs are virtual machines, with a priority assignment that in the new arrangement, if possible, the VM should remain on the original host in order to save VM migration cost. अच्छा, जब ये solution भी बना रहे हैं तो हमने एक चीज की है that most of the VM should remain on their physical machine. There should be minimum migration possible. This will occur when the ViewPick is filling the PMs or bins with the VMs, and if the original or earlier PM is capable enough of holding the VM by satisfying the resource contention or performance isolation requirements, the VM should remain on the original host so that one VM migration can be saved. There is a problem, migration has come twice. This optimization might save many VM migration costs. This is applied as mentioned in line number 11, procedure 1. We'll come to that. Yeah. So this is the algorithm. These are the kind of applications we are running in experiment. Their vectors are calculated. This was the initial setup. CPU intensive were running together, database and disk intensive were running together, database and 2 web servers were running together. Now we have rearranged it. CPU 1 has come with disk 2, web 2, CPU 2, DBMS 1, DBMS 2, disk 1, and web 1. They are having together. This algorithm is pretty simple, right? You are keep on checking to physical servers what kind of applications you have, and then you are keep on filling them. And always while filling, you are keeping in mind that whether you are placing this on the original host or not. You see the 11th line, place VM's original host in front of the queue, so that if possible, we will keep it there. So these are small innovations which can be done, right? How do we make CPU intensive, disk intensive, or all such applications? So CPU intensive, we run sysbench. Disk intensive, again we run sysbench, but with file IO. Network intensive, we run an Apache web server, an AB, and for DBMS server, again sysbench with OLTP, transaction benchmark. So sysbench is a good tool which can generate CPU, network, and disk, all such things. The kind of VMs we are running, what kind of vectors they have, these are the kind of vectors they have. How do we decide these vectors? We see their utilization, continuously utilization, and based on certain thresholds, these are given. So initially the machine for them was this. After this, new host are these. Now I would like to talk about one interesting thing. It might so happen that after doing allocation, you realize that all the VMs did not get suitable places. Might happen, right? and there will be some interference which is possible. So one way is you go live with it. The other way is you tell to Cloud Manager that there are VMs which will face performance interference and I don't have any place to place them. So this is a message which can be generated, right? So this is the paper. Those who are interested can read this. This is an interesting work. Even you can repeat these experiments to see how virtual machine placement should happen. This is a realistic experiment on real machines which has happened, right? Okay, now let me go to the second topic, which is VM backup. So before going on to this, let me talk a bit about what VM backup is and how ideally we take backup. So virtual machine backup is, or let us forget about virtual machine for some time. How do you take backup? Can anybody tell me? How do you take backup of your laptop?
We store it in some external hard disk or available storage device.
Okay, and at what interval you do this?
Like whenever necessary. So
Whenever necessary. So how do you feel? So today is it necessary, or you don't think today I should take a backup?
no, so the frequency actually depends on how important your work is, right? Like if I am doing something important work, then I'll back up more frequent than others.
But is your strategy foolproof that whenever there is a failure, you will be able to retrieve all the data?
No.
So what should be an ideal strategy?
So backing up at a regular interval, like let's say a month or two.
Mhm. Every month? You said every month, right?
Yes, yes.
Okay. Anybody else who has some other experience? Anybody else has a pain of, losing a lot of data because not taking backups? किसी का अनुभव नहीं है ऐसा? Okay. See, this is our personal data, so we are taking infrequent interval based backups, right? Whenever we feel so, we take backup, right? Somebody else is taking backup, we think that we should also take a backup, right? Our exams are over, everything is over, let us take the backup. This is student life. In professional life, we need to have very frequent backup, but I should say regular intervals, or this interval should be decided so that backup can be taken. But I'm not talking about personal data right now. I'm talking about production data. Think about any website. At what interval they should take backup?
So as WhatsApp does, it takes backs up every night for after 1 or 2.
Every? Can you repeat again, Sarthak?
So as WhatsApp does, they always take backup almost every day.
Every day. Okay. So suppose today your application fails, so it will recover you to the data of yesterday. Yes.
Yes, sir.
Okay. And if it is
Might
taking
be.
an online backup, continuous backup, it will recover you to the same time. तेरा 1:46 पे फेल हुआ, 1:46 पर जितना भी डेटा था उसका बैकअप है, and then it will recover you to the same point, and you would be very happy that I have backup. Okay. But if you take continuous backup, what will happen is that you will have files available to you. But what will happen if you are thinking about a transaction database? How will you take backups? Right? So one is storage backup, other one is transaction backup, log backup. So virtual machines provide a new way of taking backups. And this backup comes in the two forms. One is clones and second one is snapshot. Let me give you an example. Today, October 7, 2022, right? Let us say before 1 year, on October 7, 2021, I started taking backup of my VM. So what is this schedule? This is the timeline of 365 days. On day 1, this is October 7th, I took a backup. And every day I'm taking a backup. At what time? Midnight. Midnight 12, I automatically take backup every day. What is the backup? The whole VM contents, its disk is copied and a copy is created. So I say that a clone is created on the machine. Disk size is 20 GB. For example, so I create another copy of 20 GB and I feel happy that I have a copy of the whole VM disk, because if VM disk will have the everything, applications, data, personal data, right? Operating system. And that copied disk is capable of running the whole virtual machine. So every day I have this backup, October 7th, October 8th, October 9, 10, every day I have. Now what should we be doing? Suppose on October 7, 2022, I say that I want to go on January 1st, 2022. That VM I want to start. So you have clones, 365 clones are available. You just go and start the January 1st, 2022 VM, and you will be running the same VM which was there on Jan 1, 2022. Okay. Now the question becomes a little more precise and say that I want to run Jan 1, 2022, but whatever was happening at 11 AM in the morning, that situation should come, because after that I installed certain patches which I don't want to run. So January 1, 11 AM, what should we be doing? 11 बजे कैसे पहुंचे उसमें? Because whatever VM you are getting here is midnight. Jan 1 midnight, or whatever you call it, 00 hours, right? 31st December, midnight, Jan 1 started. At that time, we take the backup. Okay, but I want to reach little further. I want to go to this location, which is known as Jan 1, here, 11 AM. How can I reach to that position? Any idea? Because in these 11 hours, so many things have happened on that VM, and I don't have the data. Other thing I have is I have a VM of Jan 2, but I want to reach to 11 AM in the morning. Any idea what can be done? Or is it not possible? See, one thing I can do is every hour I take a backup. Every hour. But every hour, if I create a 20 GB copy, it will create a huge backup. See, even 20 GB every day is created a huge storage. And storage is, cheap, but it is bulky, right? So what can we do? We can go to another very important thing, which is known as snapshot. Snapshot. What is a snapshot? Snapshot is a very interesting stuff. So on Jan 2022 at 1 a.m. Instead of taking a clone, I take a snapshot. What is snapshot? Snapshot is the difference in the contents of VM right now, okay, and VM at midnight. Content ka difference that I will store in a file that is known as snapshot. At 2 a.m. another snapshot, difference of the contents. 3 a.m. another snapshot, difference of the contents. Snapshots will have smaller size because it is just the difference, not the complete VM. The difference will come. Some people also call it as checkpoint, difference in checkpoint. This is snapshot I will be taking. So every day I will take 22 snapshots. Why not 24? Because there are 2 clones. In between there are 22 snapshots. Every hour there is. तो अब कोई कहता है कि मुझे अक्टूबर 7 को सुबह 11 बजे क्या थी स्थिति VM की, I want to see. Take the VM of October 7, October 6 midnight, you can say. And after that, apply 11 subsequent snapshots on top of that VM. You will get a VM having October 7 as the date and a content and 11 a.m. as the time. Do you think it will work? Is it a great thing? Because this provides you continuous checkpoint, continuous snapshots or continuous clones. Then you don't need to worry about anything. Whatever was the situation of the VM, you will get those contents, right? So it provides you a different kind of backup, right? In transactions, we talk about rolling back or committing transactions. The transactional level backup they are not providing. In that case, you need to also support these snapshots with a log file of transactions. So suppose somebody says, I want to reach to 11 a.m. at 11:35 a.m. So why don't have a backup? I only have backup 11 a.m. and then 12 afternoon. Between that, if you want to go somewhere, I'll consider this log file. This is very minute. This is little coarse grain. This is very coarse grain. So clone, snapshot, and log file makes the whole solution very interesting, right? So this provides you a good solution. And if you are working with any hypervisor like VirtualBox, Gen, they all provide this cloning, snapshot. Log file is traditional transactional, but clone and snapshot is provided by virtual machine monitors. We should all try and use it. This is an interesting stuff. And whichever VM you are using, you can also take continuous snapshots, store them there so that you have the whole backup. But the recovery is only possible by applying the snapshot on the VM. You cannot apply it on any VM. The same VM should be there, the previous state, and then you apply the snapshot. So if you understand this, let me talk about an interesting example of cloning and snapshot incorporated in a single solution. And the solution is here: secure backup and recovery management in virtualization. This cloud computing course generates a lot of researchers. Every year there are few students which work on new research problems. So one student like you started taking motivation from this class and worked on her master's thesis on secure VM backup and vulnerability removal. So there was an additional aspect of security. I'll come to it, but let me directly come to what she proposed. She proposed this. I think this is visible. Her tool name is VM Saver. VM Saver, what it does, it creates backup of virtual machines. So what kind of backup you want? A pure snapshot based backup, a pure image based backup, which is clone, or a hybrid backup, जो से मैंने बताया पहले क्लोन लो रात को 12 बजे, उसके बाद हर एक घंटे में snapshot. These are the three kinds of backup you can offer. Most people which want fine grained backup, they will go on hybrid backup. After that, you should do antivirus scan of the current VM. You know, I told you that there is a second part of the problem which she addressed. This is vulnerability removal. So before going to that, let me describe what the problem is. 365 days you took the backup and you have 365 VM clones, right? And the VM is right now running October 7, 2022, and last 1 year you have 365 clones. Suppose today you identify a bug, vulnerability, malware, malicious software on your VM, and you want it to be removed from all clones because you don't know when it was introduced, when it came to your machine. What will you do? How can you identify whether this bug was present on October 7, 2021, 8, 9, 10, November, December, January, February, any date, right? So this, scholar, what she did, she mounted every virtual machine clone and searched for the same bug again and again. Remember, it mounted, it did not run the previous VM. Mounting and running is different. Can anybody tell me what do we mean by mounting? What do we mean by mounting? See, mounting necessarily means mounting a file system, mounting a VM disk. So when I'm mounting it for reading the contents, not running the VM. So we will mount it, repair the disk, and again store it. This is what they are doing. Antivirus scan of current VM if vulnerability is detected. No, it is not detected. Then everything is safe. If it is detected, then repair or delete that file in current VM and power on the previous snapshots or mount VM image or power on VM image for checking same vulnerability one by one. So every VM you are doing it. If found, repair or delete vulnerable file. Otherwise, there is no such vulnerability. Remember, whenever you are going backward, a VM comes where there is no vulnerability of this type. It means in previous versions also that vulnerability will not be there. Repair, delete vulnerable file after they take a new snapshot or a clone or a hybrid backup. This is the overall solution which she proposed, right? It is an interesting work. Involved a lot of coding as well as it practically works. So I already gave you this example: snapshot based approach, image based, which is a pure cloning based approach, and hybrid approach. And this, this is main virtual machines, and old backups are mounted. Mounting means you're just mounting them as files. You are not running them, right? Okay. So the VM backup part, I hope you understood. I would also suggest you to practically do this. If you are working on VirtualBox, go to the right top corner. You will have a button known as snapshot. If you click the snapshot, you will be able to take the snapshots of the VM, and those snapshots can be applied later if you want to. If you have a old backup clone, right? Okay. Any questions you have? So far, so good. Now, I'm talking about another topic which is very important from the industry perspective. Cloud interoperability. Cloud interoperability. Can anybody tell me what is interoperability? Any idea? नाम सुना हो? Interoperability का हिंदी में क्या मतलब होता है? What is interoperability? Anybody? किसने भी नहीं सुना है ये नाम? Interoperability. Okay. See, one of the major idea to move to cloud was, cheap resources, pay as you go model, higher hardware utilization. Another very important point in the cloud was quick exit. If I want to move from one cloud to another cloud, that should be seamless, that should be easy. In that case, whatever applications, VMs I'm running in one cloud, I should be able to run them on another cloud. Or I can have two different VMs on two different clouds and they are talking to each other, they are working together. That should also be possible. I may have my application server with one cloud, database server in another cloud. That should also be possible. I may want to do this for cost consideration, or I like some services of one cloud, some services of another cloud, or the cost of one cloud is considerate as compared to another cloud. So I want interoperability. Multiple clouds should be able to compose services. Or I should be able to move from one cloud to another cloud. This is known as interoperability में बहुत सारे सवाल आएंगे. One virtual machine which is capable of running on VirtualBox, it should be able to run on Gen. It should be able to run on VMware. All sort of things will come, right? So interoperability is required. It's a very important thing. Everybody who is going to cloud, they would always ask this thing that the cloud should provide me a lot of flexibility in terms of interoperability. So I will be talking about this small paper on interoperability by University of Hong Kong. It talks about cloud interoperability, taxonomies, standards, and practice. So standards, practice, what is taxonomy? What do we call a taxonomy?
Nomenclature.
Nomenclature. Anybody else? Taxonomy. इससे पहले कभी नाम सुना है taxonomy का? So taxonomy is a very important term for all people who want to become researchers. If not researchers, if you want to become developers, then also this term is important. Taxonomy says what is the classification. Suppose somebody says, sir, you work in security. Security is very big. What do you do? Then I say, I work on network security. But network security is also very big. What do you do? Then I said, I work on cloud security, malware security. Now there are few people who understand this, but still there are many, thousands of people we know who work on cloud security, malware security. Somebody says, what do you work on cloud security? I say, I work on attacks and defenses. Which attacks? I said, I work on, DDoS attacks. What sort of DDoS attacks? I say, I work on application layer DDoS attacks. So we are started from root and reached to such a leaf. Even we can go there, that we work on network layer, we work on application layer, we work on collaborative solutions, we work on ML based solutions, right? All such things. So ऊपर broad है, नीचे जाते थे बहुत specific हो जाता. But if I create a diagram of network security showing all branches, all specific areas, then going there, deep and deep, and a complete picture if I show you of all things which constitute network security, this will give you a great idea as a starting researcher, as a starting student. This is known as preparing a taxonomy. Why that taxonomy is important? Anybody who wants to work in that area can see the whole thing together. It may not be complete, right? Everybody does it in their own manner. And second thing is they can tell If this is a big cricket ground, I only work on this small point. What small point? I work on, APT malware. Very small point. Malware are so many different kinds, different methods. There is a specific malware known as APT malware I work on. So this is how taxonomies become important. So you create classification, and classification gives you a complete picture. And then you can also say that I work on this specific point. So whenever you are searching for topics of research, BTech projects, start reading taxonomies. Go in Google Scholar. Suppose you are interested in ML. Start reading a taxonomy. There are multiple taxonomies available. You want to work in malware analysis. You want to work on sensor network. You want to work on computer vision. Right? You want to work on steganography, information hiding, distributed systems. All places there are taxonomies available. They give us a complete picture of the overall area. With this, I start reading this paper. And there is a very interesting, line which has been written here. Cloud computing has become a lot like the Hotel California. Once you pick a provider, you can check out anytime you want, but you can never leave. Hotel California kaisa hai? You can check out, but you cannot leave. So people came to cloud with some assertion. Assertion was, whenever you want to leave this cloud and go to another cloud or your on-premise service, you can go. There is no problem. This assurance is needed. Otherwise, why people will come to a cloud? And remember that whatever I said is theoretically correct, but practically may not be correct. Think about certain web application you created, and that web application is written on top of a web server in a specific language. Language requires a license, and that license is provided to you by a cloud provider. They provided you a VM license, studio, you created your application. Now after 1 year, you want that I want to move from this cloud. The costs are huge. I don't want to run it here. I want to move. Can you move? The answer can be binary, yes or no. But most of the time, the answer may be no. Why? Because if you move, there are upfront costs of buying licenses, studio, development, and if you want to change language, there are a lot of concerns. It is complete redevelopment, redesigning. So what has happened? You are locked in, and this is known as vendor lock-in. ये बहुत बुरी, चीज है infrastructure में, vendor lock-in. You are encaptured by a vendor because of specific technologies. So what will you do? You will stay back. तो ऐसा नहीं होना चाहिए. This paper says that cloud should be completely interoperable. Going from one place to another place should be easy. Okay, now what should we be doing? We should be doing this. Let me directly come to this summary. How interoperability can be provided. What things should be considered while doing interoperability check? Remember, this is infrastructure as a service cloud, not PaaS or SaaS cloud. Their things will be different. But for a summarily discussion, I chose infrastructure as a service cloud. So there are 7 areas which requires interoperability. What are those? Access mechanism, virtual appliance, storage, network, security, service level agreement, and other. These are the 7 places where interoperability should be considered. Now, what do we mean by interoperability by talking about each 7 of them? But what are the ways by which these things are possible? All such ways, if they are available, then we are easily movable to another cloud. The first one is known as access mechanism. How do you access your VM if it is on cloud? Basically, there are 3 methods: API, GUI, and CLI. API, application programming interface, GUI, graphical user interface, and CLI, command line interface. इसके अलावा कोई तरीका है? नहीं. most of the people will use GUI or CLI. Those who want to do additional things, they will use API. Every cloud provider provides their API. Amazon AWS API, Jane API, which is also known as X API, right? Azure, Microsoft Azure API, Google Cloud API, they all have their APIs to access the virtual machines. This is first thing. So if these three methods are available on one cloud, they are also available on second cloud, and the same API can be used, then interoperability is there. At least if the same API cannot be used, there are wrapper function available which convert them, then also it can be done. If that is also not available, at least CLI and GUI should always be available. Second thing in this diagram is virtual appliance. What is virtual appliance? We have heard about kitchen appliance, hardware appliance. What is virtual appliance? See, virtual appliance is nothing but a virtual machine disk having operating system, application, software, complete package included in a CD or a pen drive or a folder or a zip file is known as virtual appliance. So suppose you are a software company, you create a software and you also go and set up that software at client's place, but now that is not needed. You just create a virtual appliance. Virtual appliance is a disk having virtual machine. In that virtual machine, an operating system is there. Your software is there, complete setup, configured, and you are giving the disk to the user. So user can get the VM disk and start it on a virtual machine monitor. Complete setup will be ready. This is known as virtual appliance. So the software industry ka jo packaging standard tha, that also has been changed because of virtual appliances. So the idea of a virtual appliance is to deliver a service as a complete software stack installed on the VMs as proposed by DMTF. This is a very important agency in cloud standardization, DMTF, Distributed Management Task Force, DMTF. What they do, they created certain standards for every virtual appliance. So according to them, there are three things which are important. First one is life cycle. As defined by DMTF, the 5 stages of the life cycle of a virtual appliance, a virtual machine disk, is develop, package, package, distribute, deploy, manage, and retire. Retire means it is no more usable. So develop, you create the virtual appliance. Package and distribute. Packaging means creating the file. So there is a specific format known as OVF. जितने भी virtual appliance है उनका format है OVF. .ovf, Open Virtualization Format. You create a package, distribute it, deploy means you use it, manage it. Once you are done, you don't think that this is any more useful, you just retire, right? So this is a very good thing. Pre-configured virtual machine you are supplying and everybody can use it. But one virtual machine appliance should be used, can be used at another virtual machine, hypervisor, that should be done. And the VM, if it is created for full virtualization, that can run on para virtualization, hardware assisted virtualization, OS virtualization, right? So that point is covered in next 2 points, virtualization platform and virtualization manager, which hypervisor, and second is which platform you are running it, right? Platform can be kind of virtualization technology and kind of hardware. It should be able to run on any hardware. Then only it will become interoperable. Third thing comes up about storage, right? Storage is what? Backup, replication, and snapshot. Right? We have just now talked about it. Backup, VM clone, and snapshot. What is replication? Cloning, copying. So if they are available on one virtual machine platform, they should be available on another virtual machine platform. Network. This is very important point for interoperability, because through networking you get connected to the outside world, you offer your services, right? So what is that? Addressing and application level communication. So your addresses should remain with you, but it is very difficult. With on one cloud provider, whatever virtual machine IP address you got, you may not be able to carry forward it on another cloud provider, right? So that is there. Application level, but if you have a live IP address which you got as an internet connection, then you can carry it forward. Application level communication, the API should be RESTful. What are RESTful APIs? Those which run using HTTP, right? So that is available. And if you are RESTful APIs, then they are interoperable, right? Because they are governed using HTTP, right? There are two major communication protocols, RESTful APIs, HTTP, we all know this, and XMPP. This is a very interesting protocol, XML over TCP, to carry data between web services. Fifth thing is security. Security is how do you do authentication, authorization, accounting, encryption, right? What is authentication? Authentication is username and password credential based entry into VM. What is authorization? What services I can use, what is my power, reading, writing, executing, what files I can access, that is authorization. Accounting, how many resources you used. Because when you are running in cloud, they will create a billing, right? Pay as you go model. Hourly charges, monthly charges, weekly charges, per CPU charges, per GB of RAM charges, data transfer charges. That accounting we also need to see. And finally, encryption. There are different encryption technologies available. Some cloud uses some of the encryptions, other cloud uses other encryptions, but they should come to a common platform. They should follow same encryption policies. Otherwise, interoperability is not possible. Another important point where I would also spend time in our next lecture a bit, because next lecture will be our last meeting, on service level agreement, SLA. It is an agreement between cloud provider and consumer. So if I go and work with Amazon, they have different SLA. If I work with Rackspace, they have different SLA. Work with Microsoft, they have different SLA. Can they have similar architecture based SLA? So that when I move from one to another, I don't face problems, right? So SLAs are ubiquitous in modern IT systems in terms of cloud interoperability. Four important topics are involved on cloud SLA: architecture, template format, monitoring, and SLA objectives. Architecture means the format here. Template format, which also comes in template format. Monitoring, how do you manage the SLA? In SLA, you wrote that the service will not be down for even 1 hour. How do you monitor? What will be the penalty? Right? And what are the SLA objectives? These things should be clearly defined in SLA document. In reality, I should tell you, I would be very frank. In papers, we study so many things about the SLA. We'll talk about it. In reality, companies do not give all the details in SLA. All the things are, not very, very clear. They are written legally, right? So that there is no onus. But that is part of the game, right? So these are the 6 points which should be kept in mind before designing an interoperable solution. Okay. Now I would spend couple of minutes on standardization activities, that what are the companies, what are the organizations involved in cloud standardization. You may want to note down their name. OVF, which is Open Virtual Machine Format. This format creates virtual machine disks in an open format, so that you can move from one cloud to other cloud, one hypervisor to other hypervisor, right? The other important association is known as CDMI, Cloud Data Management Interface, and OCCI, which is Open Cloud Computing Interface. They all work on interoperability, right? So IEEE, ACM. Similarly, these are the organizations which work on these issues, right? That how we will provide interoperability. Some of the cloud, software which follow some of the interoperability issues include OpenStack, very popular cloud. The biggest open source cloud project is OpenStack. I would strongly recommend you to install this. Eucalyptus, OpenNebula, right? And this portion is not needed for our discussion in this course. Only this section till section 5 we need to discuss. Okay. So here I take a pause. Please go ahead in case you have any concerns, any questions. You can take them forward. And in the next meeting, I would focus on certain important issues, 2-3 issues related to cloud, and then our discussion related to cloud computing will be complete. I would also suggest you to bring any questions you have, even in the next meeting, right? Even today you can ask, right? Yes, Kirtan.
Yes, sir. I think we can stop the recording.
Yeah.